Welcome to R.M.K. CET. I am Pratima, working as Assistant Professor, EC Department. I am dealing the subject Signals and Systems. In this video lecture, we are going to see classification of signals. The broad classification of signals, continuous time and discrete time signals. Signals are broadly classified as continuous time and discrete time CT, DT signals. Under the CT and DT signals, once again the signals are classified into below classes: periodic, aperiodic signals, deterministic and random signals, even and odd signals, energy and power signals, causal and non-causal signals. All the CT and DT signals once again classified as CT periodic, CT aperiodic, DT periodic and DT aperiodic signals. So likewise CT and DT signals once again classified based on their characteristics. CT and DT is broad classification of signals. Next. So continuous time, what is first? Continuous time signal and discrete time signal. Continuous time signal, it is defined for each and every instant of time. Usually signals, the x-axis is time and y-axis is amplitude, you know very well. And this amplitude of the signal exists for each and every instant of time. At time t is equal to 0, we can find what is the amplitude. At time t is equal to 1, we can find what is the amplitude. Similarly, at time 0.1, what is the amplitude? We can find out. 0.001 at pinpoint at each and every instant of time, whatever may be the time. It may be 0.0001. We can have the value for continuous time signal. Coming to discrete time signal, it is defined only for integer values of time. In continuous time domain, the x-axis is taken as small t. In discrete time domain, x-axis is considered as small n, where n is integer values of time. At time t is equal to 0, the signal have amplitude. Next value at time t is equal to 1. Next value at time t is equal to 2, and so on. Similarly, -1, -2, -3. So only for integer values of positive as well as negative integer values of time, only having amplitude values. So that is nothing but discrete time signal. This is broad classification of signal. Next, under CT, we are going to see periodic and aperiodic signals. What is meant by periodic signal? Periodic signal means if a signal repeats its pattern after particular time, that time is said to be fundamental time period. If it repeats its pattern, its shape, then that signal is said to be periodic signal. Periodic signals, mathematically they have represented like this: x of t is equal to x of t plus capital T. If there is a small possible value of t such that x of t is equal to x of t plus capital T. For discrete case, x of n is equal to x of n plus capital N. Then that signal is said to be periodic signal, and the fundamental period is capital T. The smallest possible value of t is said to be fundamental time period, and this is the relationship between fundamental frequency and fundamental time period. If the signal is not satisfying this property, then it is aperiodic signal. It won't repeat its pattern. So this is this graph showing example for periodic signal. So here is a pulse, and this pulse is repeated after some time. For after same time it is once again repeating. So it is repeating its pattern. So it is periodic. But here in second graph, it is not repeating its pattern. So it is aperiodic signal. Only one pulse exists in second one. It is not repeating its pattern. So it is aperiodic signal. This is about periodic and aperiodic signals. Next classification, deterministic and non-deterministic signals. So deterministic means if a signal can be represented by using a mathematical equation or formula, then that signal is said to be deterministic signal. So we can predict the values of deterministic signal before itself. For example, x of t is equal to sin t, x of t is equal to e power j omega t, x of t is equal to cos t, like that. So at any time we can predict the value. That type of signals are said to be deterministic signals. This first graph is showing example for deterministic signal. At each and every instant of time we can find the amplitude of the signal. Next, random signals. Random signals won't have any mathematical equation. We can't predict the amplitude of the random signal. It changes. There is no relationship between standard relationship between signal with time. We cannot predict. They won't have any mathematical expression. This graph is showing example for random signal. Next, even and odd signals. So in continuous time, first we will see what is meant by even signal. If the signal satisfies the condition x of t is equal to x of minus t, that means if the signal is symmetric about y-axis, then that signal is said to be even signal. This first graph is showing example for even signal. For positive values of t, the same it is having amplitude for negative values also, same amplitude. So that signal is said to be even signal, and this is the mathematical expression for even signal. Next, coming to odd signal, if the signal satisfies this property x of t is equal to minus x of minus t, then that signal is said to be odd signal. So odd signal looks like this. It will be antisymmetric about t is equal to 0 axis, and these are the even and odd part of continuous time signal. Any signal can be represented in terms of even part plus odd part. X of t is equal to xe of t plus x naught of t, where xe of t is even part and x naught of t is odd part. These are the formulas. I hope you have seen already the operation on signals video. So from that you know how to plot x of minus t, how to calculate x of minus t. So calculate x of minus t and substitute here to find out even and odd part of the signal. Next, in dt, that is a discrete time domain, even signal the same, but instead of t we are using here n, integer values of time. That's why we have used n. Even signal. This is the graphical representation. First graph is showing example for even signal. Second graph is showing it is antisymmetric about x-axis, no? That's why it is odd signal. These are the formulas to calculate even part and odd part of the any signal. So if a signal is even signal, odd part will be 0. That is x naught of n is equal to 0. If a given signal is odd signal, so x naught of n exists, xe of n is 0, like that. If the signal is neither even nor odd, then it consists of both xe of n x naught of n. X of x of n can be represented as x of n is equal to xe of n plus x naught of n. So this is about even and odd signals. Next, energy and power signals. So this is one of the important topic under classification of signals. What is meant by energy signal? Energy signal means we have some formulas. Using those formulas we will find out energy of the signal as well as power of the signal. If energy is finite and power we got 0, then that signal is said to be energy signal. And if power is finite, energy is infinite, then that signal is said to be power signal. And few cases neither energy nor power signals also there, where both energy as well as power are infinity. And one more point you need to note, energy signal, power signals are mutually exclusive. That means if the given signal is energy signal, it should not be a power signal. If the given signal is power signal, it should not be a energy signal. And one more hint is, all the periodic signals are power signals, all the aperiodic signals are energy signals. These are the calculations to calculate energy and power. Energy is equal to minus infinity to infinity u of t modulus of whole square dt, and limit t tends to infinity 1 by 2t integral minus t to t modulus of u of t whole square dt. So this is for unit step function. So you substitute u of t value as 1 and limits will vary from 0 to infinity. So you will get energy as infinity and power as finite. So it is a power signal. P is finite, E is infinity, so it is a power signal. Unit step function is a power signal. Like this, for any kind of signal we can find out E and P values and we can classify whether it is energy signal or power signal. Next classification of signal, last classification of signal, causal and non-causal signal. In continuous time domain, first we will see what is meant by causal signal. Causal signal means if the signal exists are defined only for positive values of time, that is right hand side only the signal is there, means that signal is said to be causal signal. Non-causal signal, if the signal is defined for both time index, that is negative time as well as positive time, the signal is present, means it is non-causal signal. So what is the best example for causal signal? Unit step. The first graph is showing unit step function. It will be defined for, it will rise at t is equal to 0 and it will remain 1 for all positive values of t. So it is a causal signal. Right-handed signal is nothing but causal signal. If the signal having values for negative time axis also, means it is non-causal signal. One more classification in this, anticausal signal. Anticausal signal is nothing but it is defined only for negative values of time. Time t is equal to minus 1, it is starting, that the signal is nothing but u of minus t minus 1. So it is shifted version of unit step. So it is having values, amplitudes for negative values of time, that's why it is anticausal signal. It won't have amplitudes for positive values of time. This is for continuous time domain. The same for discrete time domain. In discrete time domain, causal signal example and expression, non-causal signal example and graph. Next, for anti-causal signal, it is only defined for negative values of time. So this is about classification of signals. So this slide is showing formulas to define whether the given signal is energy signal or and power signal, periodic or aperiodic signal, the given signal is even signal or odd signal in both continuous time domain and discrete time domain. These formulas will help you to define whether the given signal is which type of signal. I hope you have understood something about classification of signals. Thank you.